Hello and welcome to my channel. In this video, which is going to be a little long, I'm going to configure Mpls, but I'm not going to give you any theory. All I'm doing is to configure Mpls step by step, and I'm going to test it. That's going to be, I don't know how long it's going to be, maybe an hour, and I'm going to show you everything that I need to have in my configuration. But before doing anything, what I'm going to ask you is to click on that subscribe button. Also, there is a bell button there. If you click on that and activate that, anytime that I post a new video, you're going to receive it as soon as possible. Give me a thumbs up too. That's going to encourage me to create more of these kind of videos for you. All you need to know is most of the configuration is going to be done on provider edge routers. Inside my ISP, router 3, 4, 5, and 6, they are going to be my provider routers. They are not going to be configured with BGP. Only provider edge routers Pe1 and Pe2 are going to be configured with BGP. Also, I have only one customer in this configuration. You can have multiple customers, but you need to first of all configure the first one so that you know all the configuration that you need to have, and after that you can configure more customers by adding those to the configuration here. So let's do this step by step, and first of all I'm going to go to provider edge 1 Pe1 and configure everything on this, and I'm going to replicate everything to Pe2 later. So let's go to Pe1. First of all, let's see what we have here. Show IP interface brief tells me that these are the interfaces that I have. One of them is connected to router 3, one of them to router 4, and this is the loopback interface that I have. This is of course 24-bit, and this interface which I have here, this is connected to my customer. Also, if I check show IP protocol, you can see that almost all interfaces have been imported into OSPF except the interface which connects to the customer, which means that OSPF doesn't have any information about that. Later I will redistribute that into BGP, because BGP needs to know about that interface, not OSPF. Later, of course, we will have a troubleshooting and verification, everything that we need to have on Mpls. And the next thing that I need to do is to check the VRF. If I check VRF, you can see that I don't have any VRF or virtual router forwarding here defined. VRF is going to virtualize my router into different routers. So each one of these routers is going to have its own virtual routing table. Each virtual routing table is going to have information about that section of network which belongs to just one customer. I'm going to enable VPN, so everything is going to be redistributed, or let's say distributed to the other side, not redistributed, distributed to the other side with the correct label binding. So let's start the configuration. The first thing which I'm going to do is to make sure that IPsec is enabled. This is necessary for Mpls. By default it is enabled, but I'm just typing this just to make sure. Also, I need to define VRFs. So I can define VRFs in two different ways. I can type IPVRF, and after that I can type a name for that, or I can just type VRF definition and then type a name for that. It doesn't matter which one you choose. This one is newer version. So I'm going to have C1 as customer 1 for this VRF definition. Two pieces of information are important for this VRF configuration that we have here. The first one is going to be the route distinguisher. This is the tag which is going to be appended to every route in this specific VRF. So I'm going to type RD, let's say 1, 1. Also, I'm going to have a route target. For import and export, of course, you can have different route targets, but what I'm going to do is to have both of them the same. So let's say 1, 1 is going to be the route target. They do not really need to be the same. I'm just doing this for the sake of simplicity. Also, in this kind of VRF definition, you need to make sure that Ipv4 is enabled. So what I'm going to do is to have address family Ipv4 Unicast, and after that hit enter. So Ipv4 address family Ipv4, and then Unicast and hit enter. So this means that my VRF is enabled for Ipv4. Of course, there are some more configuration that you can do it here, but I do not really need to do that. So what I'm going to do is to exit the Vrf configuration. So show run section Vrf. So far we have this kind of configuration for our Vrf. This is the necessary part. Now what I'm going to do is to put the interface in this Vrf, because that interface is going to belong to this Vrf. As a matter of fact, that interface is going to be connected to my customer, which belongs to this Vrf. Now that interface can be a sub interface or just a normal interface as I have here. So what I'm going to do is to type show IP interfaces brief. It says that Ethernet 00 is connected to that, and what I'm going to do is to show run interface Ethernet 00. Why am I doing this? You will know in a second. So I'm going to go to interface Ethernet 00. Because I have chosen to have Vrf definition, what I need to do is to type Vrf forwarding. If I had IPVRF, then I would say IPVRF forwarding. So Vrf forwarding, and it says what is the name of the Vrf which this interface is going to belong to. That's going to be C1, and after that, of course, I can have it downstream configuration, but I don't really want to. Now, as soon as I hit enter, it says that interface IPv4 is disabled. Why? Because it thinks that now this is going to have some other kind of a configuration. This is why I showed the information here, because I really want to copy this line and hit enter so that I know what IP address is what I have before. If you do not have this, just check your diagram and you can just figure out the IP address that you need to configure on this interface. So this interface now belongs to C1. Now that I have done this, I need to configure the routing protocol which I have between me and my customer. Now it can be a static route or any routing protocol that I have. Like I said, on this side I'm going to have Vrfs. So if I just go to C1, which is a customer, C11 as a matter of fact, and show IP protocol, you can see that I have configured Vrf here. It is configured for the loopback interface, also the interface between the two routers. This is what I have and nothing more than that. So I just go to PE1, I type router Vrf. I'm going to have this under specific Vrf. So I need to make sure that this is under the specific Vrf. So how can I do that? If I just type router Vrf, and after that, oh my god, after that question mark, it just says go under router Vrf, and after that there is something which is called address family. So I need to go to address family, but before that, let me configure Vrf with version 2 and no auto summary, which I always do. I go under address family. Why do I go under address family? Because this is provider edge, and what I'm doing is to configure everything under the specific Vrf that I have here for my customer. This is not a global routing table, global Vrf configuration. This is just a Vrf configuration. So I'm going to go under address family, and it says Ipv4. Of course, this is the only one which is supported here. Then Unicast, and then Vrf. The Vrf is going to be C1, and hit enter. Now you see that almost all the configuration that we have for the global Vrf configuration, we have it for this specific Vrf. So again, no auto summary, and then the version is going to be 2, and then the network. What is the network? The network is going to be 192.168.11.0. So I'm going to have this configured here. Now that I have done this, I can verify that I have received all the Vrf routes from the customer. Also, the customer can receive anything that I am advertising to Vrf. So if I just type show IP route, and again, I'm not checking the global routing table, I am checking this specific Vrf. So what I need to do is to type Vrf C1 and hit enter. You can see that I have received the routes from customer 1's branch 1. Okay, this part is done. Now comes the actual part. I need to configure BGP between Pe1 and Pe2. And this is going to create a tunnel, a VPN tunnel inside that. And that VPN tunnel is going to be represented by a label which is going to be added to every MPLS packet which is going to be sent to the other side. By the way, I have not configured MPLS yet on any of the routers, so I can do it simply. Let's do this first of all and then go to BGP configuration, okay? So what I need to do first of all is to make sure that safe is enabled. I did it. And then I'm going to type MPLS IP globally. This is going to configure MPLS for the whole router. Then I'm going to go to each interface and I'm going to enable MPLS for that. I can go to each interface, for example, interface Ethernet 01, and then type MPLS IP and hit enter. Or I can simply say, because only MPLS is going to be enabled on the OSPF interfaces, because as you saw, I didn't have OSPF enabled on this specific interface. All the rest of the interfaces can be configured with MPLS. So I can just go to OSPF process and say, if there is an interface configured for you, you just configure it with MPLS. So which one is preferred doesn't really matter. I go to router OSPF 1, and then I'm going to say MPLS IP auto config, or MPLS LDP auto config, right? This way MPLS is going to be enabled on almost all the interfaces. So let's exit. We have LDP here, right? LDP is by default the label distribution protocol for all MPLS routers. If you have an old router, you have the option to have tag distribution protocol, TDP, or label distribution protocol, LDP. LDP is the standard one, and now Cisco routers all default to LDP. So what I'm going to have is to make sure that LDP has a router ID. So what I'm going to do in global configuration is to type MPLS LDP router ID, and then I'm going to say which interface is going to be the router ID for MPLS LDP. So by default, loopback interface is going to be taken, so I'm going to say loopback 0, and if there has been a router ID before this, you can just force this to replace that one. So I can just type force. Of course, I do not need that because I'm just configuring this, but if you had something before, you can do that. Now that I have done that, LDP is enabled. Let me go for some verification. Show MPLS LDP, and after that there is an option that says bindings. Of course, I do not have any bindings for now. I can say neighbor. I do not have any neighbors for now. So if I just go and say show MPLS interfaces, which is one of the options here, show MPLS interfaces, and of course I can say nothing. It says that Ethernet 01 is enabled, Ethernet 02 is enabled for me. Okay, MPLS is enabled on the interfaces which I want, and you see that Ethernet 00 is not part of that. Also, loopback 0 cannot be configured for MPLS. Loopback interfaces cannot be configured. What they can be is just the ID for MPLS LDP. Okay, so this means that if I just go and check MPLS LDP, what is it? For example, the capabilities, parameters, neighbors, everything, they are going to be shown to you. Now that I have enabled MPLS, I can do the same on all other routers. I can just go to every router and start configuring. So let's go to router 3 and enable MPLS here. So what I'm going to do is to type MPLS LDP router ID is going to be loopback 0. Also, I'm going to go to router OSPF 1 and I'm going to type MPLS LDP, and that's going to have autoconfig here. Now check out what happens as soon as I hit enter. LDP is going to create an adjacency with the router that has there. So if I just type show Mpls LDP neighbors, it will say that right now I am neighbor with router 2, which is my Pe1 in fact, and it says that the connection is created over TCP, and the port 646 is the actual port number that is used for LDP. So this is my destination. My source is going to be this one because this is a random number, of course. Now, and it says that over this interface, of course, it is created. This is the ID which we have it here. So the configuration of Mpls is just done here. So let's go to other routers and do the same thing here. So enable configuration. Then I'm going to have this one. Also, I forgot to type Mpls IP, and I'm going to do the same thing on router 3 because although I know that Mpls IP is enabled, otherwise you couldn't have such thing, but just for the sake of configuration. So I'm going to go to router OSPF1. I'm going to have Mpls LDP autoconfig, and then end everything. You see the connection. So here enable IPsec is important. Again, don't forget that, but I know that CEP is by default enabled on all my routers. Mpls IP, and then this one, and then router OSPF1 Mpls LDP autoconfig, and that is done. 2 more routers to go. Then I'm going to have Mpls IP router OSPF1 Mpls LDP autoconfig. And you see 2 neighbors, and finally this one. En configuration Mpls LDP Mpls IP and Mpls LDP, and then router OSPF1 and Mpls LDP autoconfig. Okay. Now I need to make sure that all the neighbors are in place. So what I'm going to do is to go to router 5. In my topology, for example, router 5 should have 3 LDP neighbors. So if I type show Mpls LDP neighbors, Mpls LDP neighbors, now it shows me that there are 3 peers for me. So this means that Mpls is configured on all routers. The provider routers, P routers, only need this, nothing more than that. But for PEs, like I said, most of the configuration is going to be done. So far, what have we done so far? So let's show run section router RIP. This is the RIP configuration that I have done. This is not, of course, necessarily for you because I have RIP configured between the two CE and PE. This is what I have here. I haven't configured BGP so far. Also, I did some configuration for OSPF, and as you can see, this is the configuration that I have for OSPF. Nothing more than that is necessary for me. Now that I have done this, let's go and configure BGP. So I just go to configuration mode and I start creating a BGP session between provider edges. And there should be a tunnel between these two, a VPN-V4 tunnel in my case. So let's start. Router BGP, and let's say that the autonomous system number is 100, okay? And then I'm going to have a BGP router ID. I like router ID, so this is going to be 2222. And then I'm going to have a neighbor created for me. So neighbor 77777777 is the loopback interface of the other router, the BGP, the Pe2 router. And I'm going to have it in remote yes 100. This is going to be an iBGP connection. Also, this is going to have loopback interface as update source. So that's going to be loopback 0 as update source. Now that I have done this, I need to go to address family. So what I'm going to have is to have address family Ipv4 Unicast, and then I'm going to have the specific VRF that I had, C1. Now under address family, I need to first of all redistribute the routes from Vrf into Bgp. Why? Because I am sending the routes from one customer branch to another branch. So I need to have this. And anything that happens here just goes under this VRF. Global BGP table doesn't see these things. Just this VRF table is going to show us everything. So first of all, let's say that I'm going to redistribute RIP, and I do not really need to type VRF for this RIP because I am under this VRF. Everything that goes under this VRF is going to be redistributed. So if I do not have a RIP under this VRF, nothing is going to be redistributed here, right? The next thing is this. Also, I forgot to redistribute the connected. That is very important for me. Why? Because this route is, of course, not advertising to OSPF. So I need to redistribute the connected here. So I'm going to have redistribute, of course, connected, and hit enter. Now let's exit this. Now let's create the tunnel. What I'm going to do is to type address family VPNv4 and Unicast. This is what I have for the tunnel, and under this I'm going to enable this neighbor. So I'm going to type neighbor 7777 and it should be activated. Now that it has been activated, I need to make sure that the extended communities are going to be sent to the other side. So you can just say send community both, or send community extended or standard. Extended is important for my case, so I'm just going to type extended. Okay, almost everything is done in here. And nothing more is going to be done. So let's exit, and save everything. And now I'm going to do this, show BGP VPNv4, and for this specific VRF C1, I'm going to show everything. It says that VPNv4 Unicast, of course, Unicast Vrf C1, and now you see that everything that I had in RIP now is redistributed into my BGP table. This means that BGP now sees that and can send it to the other side. Okay, now one more piece of configuration here is left. I have not redistributed BGP into RIP, so what I'm going to do is to do this. Also, you see that redistribute connected? This is the one that for that. So let's go to configuration, go to rather RIP, go to that specific address family, Ipv4 Unicast Vrf C1, and I'm going to redistribute BGP, and I can assign a metric for that. Let's say, for example, a metric of 2 is going to be assigned for this. So redistribute. So what is it that I am missing here? So BGP, I forgot this, and the metric is going to be 2. So hit enter and end. Very nice. Almost all the configuration is done on Pe2. So let's review. I'm going to show run and review everything here. So you see that we have this VRF definition here. This VRF definition has been applied to interface. CEF is enabled. And if I go down, I can see that this is enabled for VRF. This is the interface connecting to customer side. Also, the rest of the interfaces are configured with Mpls. We of course verified that. We have rather RIP configuration here under address family. We made sure that redistribution is done and the network is imported. We have the BGP configuration, which has very important parts. We have this neighbor and the update source. Also, we have the VPN-v4 tunnel created. The neighbor is activated for that, and we send communities. Also, we have the VRF table. So, if you have another customer, all you need to do is to go under this VPN-v4 and activate that neighbor for that. Of course, we have done it for this, so we do not really need to do anything more than that. For each customer, what you need to have is to add a VRF like this, redistribution based on the protocol that you have, and that's gonna be almost that. So no more configuration. Of course, this is the Mpls LTP configuration for us, and that's it. Now, what I need to do is to replicate this to the other side. So let's go to the other side, Pe2. Pe2 and C12, which is my customer. Let's see what I have in this customer side. So I have show IP interfaces Vrf. This is the other branch. I have some loopback interfaces, which I'm going to advertise to the other side. Show IP protocol says that I have EIGRP enabled here. And for this EIGRP, of course, I have these networks advertised. So I need to configure provider edge with EIGRP. So let's go and start configuration here. Enable. I already have Mpls defined. What I need to do is to have the Vrf configuration. The Vrf configuration can be the same as the Vrf configuration that I have here. I do not really need to change the values for this Vrf definition. I can of course change it. Doesn't really matter. Let's say that I'm going to change it. Okay, so I'm going to copy this to Notepad. And I'm just going to change this to 2.2. That's all I'm going to do here. But of course you can have the same values, doesn't really matter. Also, the address family should be enabled for us. So I just go to configuration mode and create this VRF here. This is the first part. The next part is the BGP configuration and EIGRP configuration. Let's go for EIGRP first of all. I'm going to have rather EIGRP and rather EIGRP. Let's see what is the EIGRP here. EIGRP1. So I'm going to have rather EIGRP1, and after that hit enter. Again, I'm going to have no auto summary of the matter of fact. Again, we are not talking about the global EIGRP configuration. We are talking about EIGRP VRF configuration. So what I need to do is to do the same thing that I have in RIP. That's going to be using this family. And this family is going to be Ipv4. If it was a named EIGRP, then we could see Ipv6 as well. Ipv4, and then we have Unicast, and then we have Vrf, and let's say that the Vrf we just created was C1, and after that autonomous system number. The autonomous system number of course is 1 in my case, so I'm going to hit enter. This part is very important because we are saying the router that everything should be done under this routing protocol, under this Vrf. Then almost every configuration that I have can be applied here. For example, no auto summary can be done. Let me see what interface I'm going to put here. The interface is going to be this one. So I'm going to choose this as network 0000, and this is almost done. Of course, I'm going to have a redistribution enabled. Now, I just forgot to put this interface under the specific VRF, so let's do that. Show run. I don't know which interface is connected to that. I believe Ethernet 00 it is. Show run interface, of course. Yes, it is interface Ethernet 00. So I just go to Ethernet 00 and I'm going to type VRF forwarding. It's going to be C1. And as soon as I do that, I need to do this command one more time. Now that I have this, I should see a neighborship and adjacency created between the customer router and me. Also, I need to be able to see all the routes from there. So if I just type show IPIGRP neighbors or topology, or let's say show IP route, that is easier. Show IP route for this specific Vrf C1. Now I can see that I have received all of them into this EIGRP. Now I need to redistribute BGP here. I haven't created BGP, but ultimately I'm going to do that. So what I'm going to do is to type redistribute Bgp 100. And also I'm going to assign a metric for that. Let's say that a simple metric of 1, 1, 1, 1, 1 is going to be done here. So rather EIGRP 1, and I remember that I had something like this. If I go, I don't remember, as a matter of fact, the router remembers that, and this is the redistribution done. Okay. Now let's exit and go for BGP configuration on this side. This is going to be the final part of our configuration. So rather BGP 100, right? This was 100 as a, if I go down and find it, that's gonna be rather BGP 100. That's right. So rather BGP 100 is going to have a BGP router ID of 7777. I'm going to have, I can of course disable no synchronization and disable some other thing, for example, auto summarization, but they are not so important in my case. So I'm going to go with this, neighbor, as a matter of fact. Neighbor 2222 is going to be in remote AS 100. Also, it needs to be updated using loopback 0. So you see that now the neighborship is created. Now let's go for the Ipv4 Unicast address family. So Ipv4 Unicast for the Vrf C1. And now I'm going to have redistribution from EIGRP into here. So first of all, I'm going to have redistribute connected. This is what I'm going to do. Also redistribute EIGRP1, and that's all. Now that I have redistributed EIGRP and connected, if I check BGP and Pe4 Unicast Vrf C1, I can see that I see everything in my BGP table. Very nice. Now what I need to do is to create the other address family. That is going to be the PNETLab address family Unicast, and I'm going to activate neighbor 2222 for this. Also, I need to make sure that communities are going to be sent for them, extended communities as a matter of fact. Okay, let's check to see what we have in our BGP table now. So this is what we had before. Now I need to see everything from the other side as well. Okay, let's see what we have here. I have the routes from this side, but I do not see the routes from the other side. So I don't see 11.11.11. I don't see 192.168.11. So one problem might be the configuration that I have here. So you see that I am exporting 2.2, I am importing 2.2. I am not receiving 1.1 because the other side was 1.1. Do you remember that? So what I need to do is to change this a little bit, and I'm going to do this like this. Let's go to Pe1. First of all, show run section Vrf, and this is the Vrf definition that I have. I'm importing 1.1, but I'm not importing 2.2. So I'm going to do this. I'm going to go to configuration mode, and I can go to here. I can just remove this import, or I can leave it there. Doesn't really matter. And I'm going to have route target export, and that's going to be route target import, sorry. Import is going to be 2.2. So 2.2 is going to be imported. Let's go and do the same thing on the other side. So I'm going to go to Vrf definition C1, and let me type it one more time. Vrf definition C1, and I'm going to have route target import 1.1. This way I'm going to import 1.1, and no route target import 2.2. Okay, now that I have done this, let's see what the result is for everything that I have. Now you see that I am receiving everything from the other side, because now I have the correct route target. 11.11.11 is here, and if I go to Pe1 and check what I have here, so if I just go and check the BGP, now I see everything from the other side. Okay, now that I have these, can I go to customers and see whether they see these routes? They sure should see that. So if I just show IP route, and they do not know anything about Vrf, so I do not really need to do that. You can see that all the routes from the other side are present here. Now comes the real thing. I can ping or not. Ping 100, 100, 100, 100. I'm going to source it from one of the interfaces that I have advertised, and that's going to be my loopback interface, right? Loopback, let's say 0, and hit enter and see whether the ping is gonna work, or does it? So you see that there is a problem, and I cannot really reach to the other side. So let's go to C12, show IP route here, and see what I have. You see that I have 11.11.11 here, and in here, of course, show IP interface brief says that loopback 0 is 11.11.11.11. So I am trying to get to 100, 100, 100, 100. Show IP interface brief says that I have this. So the ping should be working, but it doesn't. Now what I'm going to do is to make sure that the trace is finding its way to destination. If it doesn't, I will go inside the ISP and start with that. So let's go and instead of ping type trace and see what happens. It goes to PE, but from PE it doesn't find anywhere to destination. Okay, let's do that. Let's go to PE and see whether we can get to the other side. So first of all, I need to do this, because here I am talking about the Vrf on PE. So I'm just type in Vrf. So after that, C1 is the Vrf which I'm going to have, and from here I can just say, for example, IP, or just type the destination. So that's going to be 11, 11, 11, 11, and hit enter. You see that from PE I can easily get to here. What about the other side? Can I get to 100, 100, 100, 100? And if I do that, as a matter of fact, because I don't have anything advertised to the other side, so the other side doesn't know how to get to me. So I need to fix this first of all. So what I'm going to do is to advertise one of the interfaces here. Let's create an interface and advertise it. Interface loopback, let's say, for example, 22. And IP address is going to be 22, 22, 22, 22. Of course, I need to apply it one more time, because I'm going to have Vrf forwarding C1 applied to this. And as soon as I do that, I need to do this one more time. Now that I have this, I need to go to rather Bgp 100, I believe, right? So I need to go to address family Ipv4 Unicast Vrf C1, and I'm going to have this network 22, 22, 22, 0, mask of 255, 255, 255, 0. Now that I have this, I need to see whether C1, 2 is receiving this. So if I just show IP route here, Now I see 22, 22, 22 here. Now I am going to repeat the ping. So the ping was this. I'm going to source it from my loopback 22 and see whether the other side can reply to me. And if I can't, I'm going to go and trace it, which seems that it's not successful. So instead of this, I'm going to use a trace route. So where does it go? It doesn't go anywhere because it doesn't know where to go. So this means that there must be a problem with the label binding or something like this. We are going to fix this in a second. To check the problem, I go to one of the core routers, to provider routers, and what I'm going to do is to type show Mpls forwarding table and see what the labels are here. As you can see, we have labels created for some of these, but something interesting happens here. It says that these are 24, not 24 bits, as a matter of fact, they are 32 bits, which is a problem in my case. And let's see why. Because I have OSPF and I have loopback interfaces. So if I just show run interface loopback 0, you can see that the loopback 0 has 24-bit mask. But if I show IP OSPF interface loopback 0, it says that this is, although 24-bit mask, but it is advertised as 32-bit mask. Why? Because this is a type loopback. So if I just show IP route OSPF, you can see that these are all advertised using 32-bit mask, which is a problem which I can, of course, easily solve. So what I need to do is to just go to configuration mode and type interface loopback 0, and I'm going to type IP OSPF network type, and that's going to be point to point. That's it. This is all I need to do to make sure that everything is going to go back to normal. So let's do this. I'm going to go to PN configuration interface loopback 0. This is going to be there, and save everything. So let's go to Pe1 and start from here. Router 3, router 4, router 5, which I have already done it, router 6, also the Pe2. So now that I have this, if I go back to router 5 and check show IP route, now instead of 32 bits you see 24 bits. Now show Mpls forwarding table, and now I see them 24 bits. These are 32 bits. This is because LDP is using that, and of course they are being dropped, as you can see, and now I have them as 24 bits. Everything is going to work just fine. So let's go to Pe2 one more time and see what we have in our BGP table. So show Bgp Vpn4 Unicast. This is a very long command, as a matter of fact. C1, and now I can see that the routes from the other side are here. Of course, I had it previously, but let's try to ping it. Let's go to Pe1 and see what we have here. The same command, I don't want to type it again. If I go to here and type it, I see this. Now, if I let's go to C12 and see show IP route, and 22, 22, 22, 22 is here. So let's see if I can ping 22. So, or let's say this, go to Pe1, that is better. Ping Vrf C1, and that's going to be 100, 100, 100, 100, and I'm going to have a source of loopback 22, and now you see that it is working just fine. There is no problem. Let's go to C1, C11 as a matter of fact, and see what we have. En show IP route. Now I'm trying to ping the other side, ping 100, 100, 100, 100, and I'm going to source it from my loopback 0. And now you see that the ping is working just fine. So MPLS configuration is done, no problem. And of course I'm going to have a review in the end, but let's see if I want to trace what happens. So I'm going to trace it to the other side. You see that it goes through my MPLS network. From here it uses these labels, and then you see that this one, which doesn't change, is the VPN label. This one is of course the MPLS label. And then finally it goes to the end, and this is just a VPN label which is going to be removed by the PE router, and then it gets to the destination. So most of the configuration were done on provider edge routers. Show run, and I'm going to show you this and see what we have. First of all, we had the Vrf definition. We made sure that export and import is correctly configured. You saw that I had a problem and I fixed it. Then I went down. I made sure that IPsec is enabled because this is very important. MPLS IP, of course, should have been configured globally, but in my case, this is no problem. The loopback interfaces that I used, because I had them 24 bits, they didn't have the correct label assigned to them. So because this is OSPF, of course, if it is not OSPF, if it was not OSPF and it was something like EIGRP, there would be no problem, and you didn't really have to do this, but here I had to. And then I put this interface, the correct interface, this one, also this one, under VRF, the correct VRF, because they are going to be advertised. Then I had OSPF, and under the OSPF I said that these interfaces which I want to had to be under OSPF configuration, had to have LDP. Also then I had REP and EIGRP on the other side, of course, but something that was important was the address family that I had here, the BGP configuration, of course, and then the BGP configuration had the Vpn-v4. This is just once, but for each customer that you have, this part is going to be reapplied. For example, customer 2, customer 3, and the correct networks or redistribution should have been done. And that's almost all the configuration. So I hope that this was informative for you. Of course, I'm going to explain everything in detail in later videos, so don't forget to subscribe if you haven't already. Also, give me a thumbs up because this will motivate me to create more of these videos for you, and hit that bell notification. You don't really know when I am going to post a new video for you. With that bell notification, you are going to be notified as soon as I do that. Also, comment and tell me what you want to know, and I'm going to teach you all of them. So this is for now, and goodbye.